Now let's take a look at using dimensions. So again, in order to use this, you should have already run the ffprop notebook because that's where we actually grab the dimensions and save them to our JSON file. So if you haven't done that yet, please go and check out that video and run that notebook before you come over here and run this notebook. I know we kind of bounce around between a bunch of notebooks, and that's more just for like sanity's sake. If we had a million notebooks, or if we had one notebook with a million cells, I feel like people would kind of lose their minds. So I'm kind of breaking this up. I think as we get closer toward the end of class, I think we'll like compile some things so it's a little bit easier to use. But for now, just run through each notebook. So make sure you've run the ffprop one before that. I'll add that note to the top of this file. Okay, again, we don't need a GPU for this, so we're just going to run this cell, but it should throw an error message. Sure enough, there we go. Okay, so let's run and connect to Google Drive, because that's where all of our files are. And there we go. And there's our drive. Okay, so now what we want to do is we want to pull in that JSON file again, kind of like what we did with durations. So we'll just go and grab that file. And if you've been laying stuff out the way I have, which I would probably recommend, at least for this part of the class, it should be directly in your root algo film folder. So just copy this path, and that will already be by default put in here. And then again, if we want to filter down by like, let's say we just want to work with one particular film in this piece, we can use this filter. So for example, like I have that Groundhog Day piece. So if I wanted to filter by that, I could just type in groundhog, and that's going to filter out any video files that don't have the word groundhog in them. I'm going to leave this empty because I actually want to grab all the films so I can show different dimensions as we go through this. So now I'm just going to go ahead and run this cell. And you'll see it like fills out this JSON, and there's a bunch of stuff in here. And another thing I should say is if you want to see how many files it actually is, you can always add a little code block here that says print len, which stands for length, and then our variable here is called selections. And I believe what we're going to want to do, let me just run this to be sure. I think this will just give me one. Oh, that does give me the entire length. Okay, so this file that I'm working with has 19,000 clips in it. That's actually not really that many, to be honest. I usually work with like millions of clips, so you'll see that loaded pretty quickly, which is great. So again, you can do that if you ever just want to see like, well, how many files am I actually working with here? That's a good way to check. Okay, so now let's come down here and run this cell. This is just going to print out all of the sort of stats about our film, about all of our variable pieces. So again, I purposely went and found a very small resolution video. There's also 4:3, so it's an old film from, I don't know, the 50s, 60s. And then I've got some other stuff that's newer, which is like, 1080p, 16:9, that sort of thing. So when I run this, it'll just spit out a bunch of dimensions for me. And that'll sort of tell me a little about like the data set I'm working with. So let's run this. And here you'll see my largest video file on the width side is 1920 pixels. My smallest is 674. My largest on the Y dimension is 1080, so that's a 1080p file. 1920 by 1080 is a very common 16:9 format. And then the min height is 480. I don't know what 674 by 480, that's probably like an Academy ratio. So it's a little bit wider than 4:3, but not by much. And then it also gives me here the min ratio. Now again, this is not really in a format that we can really read. Just know it's 1.4 to 1. That's the narrowest, which, I don't know, what is 4 divided by 3? Yeah, of course, I should know that number. Sorry, it's late. It's late at night here. So a little bit wider than 4:3, which is again probably that Academy ratio. Okay, so now that we've sort of seen this, we can kind of get a sense of like, wow, we've got some really big videos, we've got some really small videos. As I mentioned, how do we combine these? Like, this is quite large, this is quite small, and you've sort of got two options. One is you can scale up to the biggest size, or you can shrink down to the smallest size. So those are the two files that I've sort of set up here for us to play with. So the other thing to know is that these processes, you basically have to recreate each clip at the individual size that it needs to be defined at, save that to a temporary folder, and then concatenate all of them like we did with the randomization process. That means if you are generating, 2,000 clips again, it's going to be kind of slow. So what I recommend for this demo is let's play with a smaller set of clips. So in this case, there's this variable here that has said how many clips. So we can just sort of set this to whatever we want it to be. Let me just set it to 20. And then we'll go ahead and hit play. And it spits out sort of what our clips are. So now let's double check. Let's again, it basically runs the exact same sort of dimensional stuff here plus a couple extras. Let's run this and just sort of see what our data looks like. And this actually works out perfectly for me because what I really wanted to get was a wide range of clips. I wanted to keep 1920 by 1080, 674 by 480, and then a different set of ratios. When you run this, if you run this, you might actually get your min and max might be the same, meaning it only collected a random sampling of films, but from the same dimensions. That's fine. I mean, it kind of depends on what your data sets look like, but I want to show sort of what happens when you change the dimensions of things with this wide of a set. So this is good for us. Let's work off this. Next file we just want to run, which is a set of functions. So let's go ahead and run this just to set up this function for us. Great. And I'm going to go ahead and close my drive just so you can sort of see what I'm working with here. Okay, so this first cell here is just going to crop everything to my minimum dimensions. So what it's going to do is it's going to take my large files, which are these larger ones, scale them down to, usually by height, scale them down to the size that fits within this, and then crop off the left and right. That's usually what happens. If this is 4:3 and this is 16 by 9, it means it's going to crop the left and right. So just beware that, like, I don't know, if you're working with a film that, like, always has asymmetric layouts and, like, is always on the right side, like, sometimes cropping stuff like this can be dangerous. In general, it's probably fine. Again, lots of films were actually made to be cropped down because they were shown on TV, you know, whatever. So usually this is a fine process, but what we're going to do is we're actually just going to scale all of our videos down to the smallest size and crop to this minimum ratio. So we'll go ahead and run this. The only thing that you need to do here is actually like set the output path. I like to save this sort of stuff directly to this content folder, in part because this is just demo and I might not want to keep it. If you want to keep your files and make sure they don't get deleted when you shut off your runtime, your other option would be to save this somewhere here. Like, I have this output folder that I generally just dump stuff into. So you could just copy this path and paste this in here. So it would say the output path and then cropped. Let me just call this underscore test cropped. Okay, at this point we're ready to run this because this is really the only variable because we've already generated our random clips up here. And this is set to just say like, hey, we're just going to crop to the minimum size. So at this point we can go ahead and hit play. Now in this case, this shouldn't be the slowest thing on earth because we're actually making really small video files, which can generally happen really quickly. If you're working with like 4K or 6K video files, expect this process to take a long time. And if you're working with lots of long pieces, like let's say in my case, I've done 100 feature-length films, there's probably a ton of clips, and that's why I moved this down to like a small amount. You could skip this cell entirely, I think. Actually, that would probably throw an error. I might need to rewrite this code to make that happen. But you could set this to a very, very high number. Like you could even actually set it, if you remember what that was, I think it was like 1924. You could set this to the same number and it would actually pull in the right amount. So this is possible to fit everything in. Just know that if you're doing that many, processing that many pieces of film is going to take a little bit of time. You could run it overnight. Again, this isn't using a high-powered GPU, so you could run this and be fine with it. Let me show you what's actually happening while we do this. So while this runs, you'll see what gets created here is a folder called TMP and then a timestamp. This is actually generating all of our individual clips. You'll see is generating a bunch of different clips. And what it's actually going to do is when this is finished completing all the individual clips, it's going to concatenate them together into one film, which will be this video piece. At that point, it's also then just going to delete that temporary folder. Again, this is kind of to save people space because these are kind of intermediary files. You don't really need them. If you want to work with them later, I could probably throw in another like checkbox or something in here to save them if you'll want that. But in general, I would say like it's probably fine to just like delete them. One other note is because we are making an intermediary and we are using compression, your file quality will degrade a little bit. What I've done in here is I've actually used this command called CRF, which determines sort of the quality of your output. These using like 264 files. So this is actually generating like a fairly high quality 264, so we shouldn't really see that much loss in the actual video file. But again, just remember like compression, if you compress over and over and over and over again, you will like degrade the quality. I know some people are worried about production quality, that sort of thing here. If that's a case for you, let me know, and we can take a look at that. This actually still is taking quite a bit of time. I'm not sure why that is. Maybe one of these files is actually quite a long period of length. Okay, so that did finish, and you'll see here that it took about 6 minutes. Now that was 6 minutes with 20 clips. Imagine how long that would take to process 19,000 clips, or 1,900 clips. 19,000 would be very, very long. So again, this process is not really meant to redo your entire data set. It's definitely more for like a filtered data set. You'll also notice here, if I refresh, that it removed that temporary folder. So by default, it will delete that folder just to save you some space. But if I come over here and I go to Algo Film and I go to Output, you will see here there is a folder called Test Cropped. We'll download this. 77 megabytes. There must have been a long clip in there. I actually do think I was looking up here earlier while this was running. I think there's a 30-second long clip that got stuck in here. I don't know if that's realistic or not for Piscine Detect, but so it goes. And again, it takes a little bit of time. You can't really watch these directly in Colab. Because this is uploaded to Drive, you could go to your Drive folder and watch it there. But in general, I think it's probably just as safe to download the file and watch it. Okay, and this is ready to be downloaded, so let me just hit save here, and then we'll go ahead and open this. So you'll see it is much, much smaller, and in fact, if we type Command I, and we get the inspector, you'll see here that the actual size is 674 by 480, which is exactly what we're looking for, and then if we scrub through it, you'll see that all of my clips are cropped down, and you'll kind of have to believe me that there were initially larger and different scales for these, right? So there was, in fact, you can kind of see here, there's probably more to the left-hand side of this piece, but this worked. Okay, so we're ready for that. So that is cropping. This will always crop to the minimum dimensions. Next, we want to talk about padding. So again, we want to go for the larger dimensions here. And in fact, what I'm going to do for this is actually go to an even larger dimension overall. Remember that my max sizes, if I go back up here, were 1920 by 1080. So let's just add a bunch of padding around that. So we're padding around the entire image. Now I could set this to 1920 by 1080, in which case the largest files will actually have no padding around them whatsoever. And then only the smaller ones will have padding around it. But just to sort of show what it looks like, I'm going to scale this up. So in this one, for pattern on videos, again, you do the same thing. You could set your path, like let's set the path here to be this folder again. And then you set the max width and max height. And again, I'm going to set that to be slightly larger than 1920 by 1080, so everything will be padded. And here again, we'll just run this. Now this one is definitely going to take a little bit longer period of time because this is just a larger file. It takes longer time to save out larger dimensions of video. So I'm going to run this in the background. While we do that, I actually did download the file already previously, and we can look at and see what it does. So let me go ahead and pull this into our screen here. And you'll see, as we scrub through this, that the largest video, this is probably the 1920 by 1080. Actually, this is 1920 by like 800. This is wider than 16:9. This is 16:9. There's an even wider dimension. And you'll see that we are padding around it. Now, somewhere in here is a very small piece of film. There. So This is like that 674 by 480, right? And that is much smaller, so you see a lot of gap around it. Now, here's your question. Is this good because you kind of are highlighting the dimensions of the piece? Would it be better to actually set a smaller scale and only have these pieces, be a decent size and only pad around these? Again, this is kind of up to your taste. It's kind of what you want to do. I kind of like showing like the default resolution. There's something kind of nice about just seeing like different dimensions like purposely being used in these pieces, but it's kind of whatever you want to do. So if you did want to crop in or set a 16 by 9 ratio at a smaller size, you could do, let's say 16 divided by 9. So let's multiply this by, let's say, let's do like a 600. So we'll do 1066 by 600. The other thing to know is your dimensions should always be even numbers. Do not put in an odd number here. It'll usually complain and throw an error. So we could set this to be 1066 by 600, which what would happen is my other 16 by 9 pieces would be scaled down. They wouldn't have padding around it. And then some of those that are like larger, like wider than 16 by 9 would actually get letterbox. They would have black and white bars or black bars above and below. And then that 480 or the 674 by 480 would still get black all the way around it. So it's kind of like scaling everything down a little bit so it doesn't look as dramatic. That might be a better way to approach it if you're kind of depending on how you're showing these or whatever. So lots of options here. This is kind of playful, and you can kind of use these areas. What I will eventually do is I'll actually turn these into functions that we can use in every notebook. I just want to kind of walk through this process like one by one, just so people can sort of see what we're doing. So that's it for this. I'm actually not even going to try to finish this because it's going to take forever. But this will take a little bit longer because you are making much larger files. So just keep that in mind. All right. So as always, remember that when you're finished, you want to disconnect and delete your runtime. I'll just say yes here. And that's it for this video. So now we're going to jump into another lesson.